Let's do a ray tracing example with a diverging lens. Remember, a diverging lens is a lens with a negative focal length. So in the example we have an object, we have a focal length, and a lens, a negative index lens out here. We're going to say that the focal length of the lens is -1 meters in this case. And we're going to put the object, which is called Z1, at 2 meters away. So let's go ahead and trace out some rays and see what happens. Well, remember the 3 rays that we can trace. Let's first do the parallel ray. The ray that is parallel to the lens is focused down to the focal length, but remember, this is a negative lens, so the focal length is not on the right side of the lens like it should be, it's on the left side. So what actually happens here is we have to draw the ray as if it were coming from the left side from that focus. This is the reason I did this example. It's a bit tricky. So instead of the ray converging to a focus, it has to diverge away from the focus. So here we're going to draw as if it's coming from the focal point. And then the second ray, okay. Second ray we are going to draw through the center of the lens. I chose this one because the next one is a bit tricky as well. And you can already see, if you connect the 2 rays that we already have, that we know where our image is. It's right here. But we get ahead of ourselves. Let's go ahead and do the last ray. So the last ray we're supposed to draw through the focal point. Well, remember, this is a negative focal length lens, so the focal point that we need to draw through is not here, because that would actually make a ray come here, which would then diverge out this way. And you'll possibly have to take this for granted for another 30 seconds or so. But because it's a negative index, or not a negative index, a negative focal length lens, we're going to draw our ray as if it's coming from the other side of the lens, going to this focal point. Left and right are basically reversed, and you have to keep track of that when you make this. It looks like this ray needs to come down just a smidge, and then light that comes from a focus comes out as a parallel ray. And sure enough, when you trace back that, you also get, more or less with my rough artwork, where the image should be. So this is an example, but let's go ahead and round this off with a actual concrete answer of where it is. This is just a little graphical and based on my rough sketching. Generally, when you do ray tracing by hand, you need a ruler and a grid that's measured out so that you get the exact answer. And that is a bit dependent on one's ability to draw straight lines and use a ruler correctly. So let's do this a different way. Where is the image? Well, if we remember the imaging condition from the curved mirror example, it's this. Z1 is the distance of the object to the left of the lens. So this is 2 meters, so Z1 is 2, so we write this as 1/2. We're trying to find Z2, which is the distance right of the lens of where the object should be. Remember that. It's to the right of the lens. That's how this is defined. I chose this example for a reason. It's pretty tricky. Then 1 over the focal length. Remember, this is a diverging lens, so the focal length is negative. So we'll go ahead and write that. Now if we solve this equation for z2, we subtract 1/2 from both sides, so we get 1 over z2 is equal to negative 3 over 2. And then if you divide both sides by, or multiply both sides, if you invert both sides, there are many different ways to change this. You have negative 2/3 as z2. Negative 2/3. Remember, this is defined as the distance from the right side of the lens. So z2 of 1, in this case, would be right here. It would be 1 meter to the right of the lens. Since we have negative 2/3, we're going in the opposite direction by 2/3 meters. So this distance right here is z2. And we know now that this is equal to negative 2/3 meters. So you can see that my artwork puts 2/3 very close to 1, which is not exactly right, which is why it's very helpful to be able to calculate and check yourself after you're done.